All right, let's check out number 14 through 16 here. Now, the switch when we transition on this particular activity is that now all of a sudden we have bases that are just not going to match. There's nothing I could do to make these things match. So the way that I always look at it is if my variable is in the exponent, that's a bad thing. In the same way that a variable inside a radical is a bad thing. We want to kind of get rid of those extra pieces that are around it. And the way you could do that is to take a log of both sides. Now, you could use any log base that you want. I personally prefer the natural log base, and it has to do with my experience teaching calculus and taking calculus and using it. Calculus just tends to work better in base E than other bases. And if you take that course down the line, you will very quickly understand why that's the case. But what I'm going to do is take that log of both sides. And the reason I do that is because when you take a log of both sides, one of those properties is that that exponent becomes a coefficient. That exponent can pop in front. Now, the nice thing is if we took a few moments to use the distributive property, I can kind of expand this problem out, and that allows me to take the pieces that involve an x, which are right here and right here, and place them on one side of the equation, and the values that do not involve an x and place them on the other side of the equation. So notice I'm going to cluster the x ln of 7 and the 2x ln of 5 on one side, the 3 ln of 5 and ln of 7 on the other. Now, just be a little careful when you move those things around because, of course, they're changing signs because you'd subtract 2x ln 5 from both sides. And the reason we do that, so again, step one, we took a log that allows that exponent to pop in front. Number two, I distributed. That way I'm allowed to move the little independent pieces around. Step three, make sure all of my variables are on the same side together. And that means because by design, these both have an X on the same side, that leaves me with, let me fix this. That leaves me with X times this equals 3 ln 5 minus ln 7, and a quick division is going to get me home because to get x by itself, since x is being multiplied by this stuff, then I'm going to divide by this stuff. Now, again, what a terrible looking answer. One that I wouldn't necessarily feel ultimately super confident in if I was taking a test. Let's say I would want to make sure that I did okay. So I'm going to take 3 natural logs of 5 minus the natural log of 7. Now, you'll notice that I put a parentheses around that entire numerator because it's very important that all of this is on top and that all of this is in the bottom. But you're going to notice as soon as I hit ln5, my calculator added a parentheses. And so I had to close that one. And then I'm going to divide it by an ln of 7. And notice I had to start a parentheses because I need the entire denominator to be set off, minus 2 ln 5. Now, again, my story here is I always hit store alpha A. So all of that, whatever that junk is, I'm good to go. And so if I took 7 and raised it to the, let's see, A plus 1 power, I got that. And if I took 5 and I raise it to the 2A plus 3 power, hopefully I got the same exact decimal, which leaves me, I think, a fair level of confidence that I did okay. Now, I normally do all of the problems. I don't think I'm going to. This problem structurally is almost identical to this one. You're going to go line by line doing exactly the same work. You can check in class. I have an answer key available if you want to see what that answer is. But this one may look a little bit different, so maybe I'll start this one out. So again, if we took the log of both sides, remember the exponent pops in front. Then just like before, we're going to use the distributive property. 1 times the natural log of 4/3 is just natural log of 4/3. Now, this is actually an easier problem in some ways, although it looks like it might be harder. It's not really that big of a deal. I'm just going to have to move this X to that side so I can put them together. I can factor out that X. Now, this is one thing that I would probably choose to do on this story is when I divide both sides, I'm going to say it's the natural log of 4/3 divided by the natural log of this product. But remember, because there's a plus there, I can multiply those together. So I'm going to say the natural log of 20/3 because 5 times 4/3 is 20/3. Not a super difficult problem, but not too bad. Anyway, so I'll just go ahead and do this and take the natural log of 4/3. I didn't put a parentheses around it because that is literally the only thing in the numerator. Divided by the natural log of 20/3. Store it as alpha A. And we'll just double check and make sure we did okay. I got 0.15. And if we took 4/3 and I raised it to the 1 minus a power, I got 1.27 and 5 raised to the a power. Hopefully this is good. See, I actually don't usually have an answer key. I usually just trust myself, and hopefully I actually don't make a fool of myself. All right, well, I'll see you guys back in class. Bye now.